Hello students. Student, in the last class just we have to finish the exercise 1.3 that should be related to the relation and functions, and basically in that exercise 1.3 we have discussed about the basic invertible functions and how the inverse is to be existed and how the calculation of inverse is to be done. Each and everything we have to discuss in the last class. Is it to be clear? Now student, today we are just going to start the miscellaneous exercise, but before that a topic that should be related to the binary operation is to be also there in your NCERT book. But student, here this particular chapter is not to be included in your syllabus. So in a very short we will discuss the binary case, then after we will just start the miscellaneous exercise. So basically, first of all, just I will tell the some basic definition of binary operation, and this particular binary operation is not to be included in your syllabus part. So binary operation is what? Binary operation. So student, we can say that first of all the name of these type of operations are said to be the binary operation. So what should be the meaning of this bi? So bi means two, means we have to take the two different element and we have to apply the distinct type of operations between them, and any binary operation is to be applied between the two operands, means there are two terms are to be there, and yeah, you can say that there are two different kind of numbers you can take, and if we have to apply the binary operation between these two numbers, then any binary operation is to be defined in suppose set of natural number, then the answer of that part will be also lie in natural number, then it is said to be the binary operation. So you can say that let star be a binary operation. This is the symbol. Star be a binary operation. Star be a binary operation. Then it is defined as, then it is defined as star. Suppose this particular thing is to be defined from n cross n to n. Is it to be clear? And here suppose you can say that any natural number we are taking. So you can take any of the natural number here. Means suppose there are two different natural number we are taking, and we have to apply this operation. Then this will be the domain part and this will be the codomain part. Means answer should be always lie in the domain part. Suppose we have to apply the star operation like this: a star b equals to a plus b, and star defined on the natural number, star defined on set of natural numbers. Suppose we have to take this example, can we say that whether this particular star is said to be the binary operation or not? So basically student, this star is always said to be the binary operation whenever we have to take the two operand from the natural number. Then suppose we will take any of the two natural number, then definitely their addition will be also become the natural number, you know very well. So AB belongs to natural number, AB belongs to n cross n, then a plus b belongs to natural number or not, we have to check this thing. So in this case, suppose any of the two natural number a or b you can take, then definitely a plus b means the addition of some natural number will be also belong to the natural number. So it is a binary operation. So it is a binary operation. Now we will take the different example also, so that the definition part will be clear to each and every student. Suppose any binary operation should be defined like this: a star b equals to a minus b, and this star defined on natural number again, defined on natural number. Then we have to check whether this star will be known as the binary operation or not. So student, in the case of binary operations, we are taking the two operands from the natural number, and the answer of this part means, suppose this binary operation is defined as the subtraction here, here the binary operation is defined as the addition of the two numbers. Similarly, this binary operation will represent any kind of operation: plus, minus, into, divide, maximum, minimum, LCM, HCF, each and everything you can just define by using this binary operation, but that should be given always. So according to that we have to do the work, and we have to do the work means just we have to take the two natural numbers and we can check their subtraction. If the subtraction is always found to be the natural number, then definitely it is said to be binary operation. Otherwise, suppose in any of the cases we have to take the two natural number but the answer should not lie in the natural number, then definitely it should not be a binary operation. So easily you can say that let you can say that a will be equals to 3 and b will be equals to 4, then definitely student, this 3 star 4, this 3 star 4 is to be get calculated, then both 3 and 4 belongs to the natural number, but 3 star 4 will be equals to 3 minus 4, that should be minus 1, and thus this is not belongs to the natural number, means in such type of cases this particular star is not said to be the binary operation. So it is not a binary operation. This is not a binary operation. So basically student, in this particular binary operation, first of all we have to check whether the given star, basically the star is the symbol which is generally is to be used for the binary cases. So this particular star is said to be the binary or not, just we have to check this thing. And for this thing what we are doing, basically we are taking the two natural number or any other number is to be also given, but this star will be defined on which type of sets, from where we have to take the two different numbers, and we will just apply the star operation between them. And if for each and every number we have to take from the given set and the answer will be also lie in that set, then it is said to be the binary operation. Otherwise in any of one cases will be not included here, then definitely this is not said to be the binary operation. So basically what we are saying here, let star be the binary operation defined on the set. Suppose you can say that binary operation defined on set A, defined on set A. Then it is defined as star such that n cross n to n. This star is said to be the binary operation. This star will represent the either addition part, either subtraction part, either maximum of the A and B, minimum of the A and B, sometime LCM of the A and B, sometime HCF of the A and B. Means star can be defined any kind of the operations that should be included in the mathematics. So basically the given star is said to be the binary or not, just we want to check this part. That's why student, you can just take the two numbers and you can just apply the operations, and for each and every number if the process will be followed, then definitely the star is said to be the binary operation. Otherwise the particular star is not said to be the binary operation. So this is the basic definition of the binary operation you have to keep in mind. next student, in the binary operation, just if any of the binary operation is to be given and suppose it is said to be the binary part, then definitely we have to check the commutativity, associativity, as well as we have to also calculate the identity element and inverse element. There are four parts in the cases of binary operation. So student, how the commutative, and next part we will check the associative, then we will check next part as the inverse element or identity element. So before note the pause the video to note down this thing, then we will take the next part. And next part is what? Next part means you can say that if basic part of the binary operations means we have to check commutativity, or you can say that commutative property of the binary operation. So any binary operation star is said to be the commutative if A star B is said to be the B star A, then it is then star is commutative, then star is commutative. So basically student, we have to just check the commutative property like this. A star B is to be always given in the question, then just we have to revert the A and B, then B star A we have to calculate. If both the answers are to be found same, then definitely the given star is said to be the commutative. Next one is known as the associativity. Associativity. So whether the given star is said to be associative or not. So for this part we know very well, if A star, B star, C, we have to take the three operands here, but binary operation is to be applied at a time between two operands only. So A star, B star, C. So we will take here A star, B star, C, and suppose this particular part is found to be A star, B star, C, then it is said to be the associative. Is it to be clear? So A star, B star, C is to be obtained as the A star, B star, C equals to, then star is said to be associative. Star is associative. Is it to be clear? So these are the some very important properties we have to just check whether the given star is commutative or not, associative or not. Similarly, the next part is the identity element. Next part is the identity element. So this particular element is generally represented by using the symbol E, and we are saying that if A star E equals to E star A equals to A, then then it is said to be, then E is known as, E is said to be by identity element, said to be identity element. Is it to be clear? So easily student you can just check. First of all, we can just apply the star operation between A star E. We have to take the one operand as same, but another operand in place of B we have to take the E. Then we have to check A star E equals to E star A, and whether this part will be equals to taken as A, then definitely you will get the any value of E. Is it to be clear? And if any value E is to be obtained, then this particular E is said to be the identity element. Next one is said to be the inverse element. Next one is said to be the inverse element. So basically student, any inverse element will be existed in case whenever the given binary operation has the identity element. Sometime the existence of identity element is not to be there, because sometime A star is not equals to the A star A, then definitely we can say that the identity element does not exist. But suppose identity element will be existed, then definitely student the inverse element will be existed. So what we are saying in this definition, if A star B equals to E, if A star B equals to E, if E exists, if E exists, what should be the E? E is the identity element. So if A star B equals to E, if E exists, then B is said to be inverse of A. B is said to be inverse of A. Inverse of A. Is it to be clear? So basically student, if any of the identity element will be existed, then definitely you can say that inverse element will be exist. Otherwise inverse does not exist whenever any identity element does not exist. And when identity element does not exist, you can check A star A and both E star A both are not found to be equal. In this case definitely identity element does not exist. So basically student, for the existence of inverse, just we have to first of all calculate the identity element, because the requirement of identity element is to be there, because here just we have to calculate the value of B after applying the A star B, then B is said to be the inverse of A. So B can be also represented as A inverse. Is it to be clear? So easily student, you can just see the basic thing related to the binary operation here. Just these four things mainly we have to calculate for the each and every case of binary operation, that is commutative nature, associativity, identity element and inverse element. Is it to be clear? So student, this is the basic theory related to the binary operation. Just I want to tell you, but this is not to be included in your NCERT syllabus 2021 or 22, because here this is to be given in your NCERT, but this is not to be included in your syllabus, so that there should be no problem if you don't know about the any kind of the things related to the binary operations, and we are not discussing in the much more deep part of the binary operation. So student, just we have to keep in mind the thing, what are the binary operation and what are the basic properties, and related questions are to be also there. In the case of binary operations, these four questions are to be generally asked, whether the commutative or not, whether associative or not, whether we have to calculate the identity element or inverse element. So these four things are to be most importantly defined here. Is it to be clear? So student, this is the theory part of binary operation, just I want to tell you, but this is not to be included in your syllabus part. Remember this thing. So if you want to do the question of 1.4, then definitely you can able to find the answer by using these type of properties. But there should be no requirement, because no particular question from the binary operation is to be asked from your examination, because this is not to be in your syllabus. So student, the theory part is almost clear in with the of the chapter number first, that should be relation and function. Now the turn is to be do the very important work, that should be known as the solution of miscellaneous exercise, because the very important and some very uh, basic concepts again we will repeat by using the different type of questions in your miscellaneous exercise. So student, now we will start the miscellaneous exercise. There we will solve this miscellaneous exercise in two of the parts. The very first part today we are just going to start now, but after that one more part is to be there, because the questions are to be the very important of the miscellaneous exercise, and mainly the questions are to be asked in the examination from miscellaneous exercise always, so that each and every question you have to just keep in mind, and just we have to solve each and every part, and you can just see the solution, and then after you can just do the practice of writing, means how the particular answer is to be get written. Is it to be clear? So student, next part we are taking, but before that pause the video to note it down the theory part of binary operation. Then we will take the next miscellaneous exercise of the chapter number first. So we will take the miscellaneous exercise. The very first question, student, you can check here. In the very first question, let f r to r be defined as fx equals to 10x plus 7. Find the function g, and g is to be defined from r to r such that gof equals to fog equals to I of r. I of r means identity relation. You can say that identity function. So basically, student, in the very first question, a very simple thing is to be given, means just we have to find a function g that should be defined from real number to real number, and such that gof and fog both are said to be I of r. So we will take the question number first of the miscellaneous exercise. So basically, student, if we will take the question number first, then in this question number 1 of the miscellaneous exercise, very first part is to be given as any function f is to be defined from r to r, and this fx is to be written as 10x plus 7, and just we have to find the any function g r to r, and just we have to calculate this particular function such that such that such that fog equals to gof equals to I of r. Means you can say that a very important definition, student, in the composition part we have already discussed. If any of the FOGX, fog or gof will be equals to the identity function, then definitely G is said to be the inverse of F, and you can say that F is said to be the invertible function. So basically, student, here we know that we have to use the definition. We know that if F is to be defined from x to y, then if any function g will be defined from y to x in such a way that FOGX equals to g of fx equals to identity function, means you can say that ix or iy, then g is said to be inverse. G is said to be inverse of f. So student, this thing we have to discuss in the theory part, means any of the function is to be there, suppose f x to y, and suppose let g is any function, that should be codomain of this part will be domain, and domain of this part will be codomain here. So this will be defined in such a way that FOGX and GOFX both are found to be identity function of x or y, then definitely this particular function g is said to be the inverse of f. So this particular thing and this particular theory part we can use in this question, and here the conditions are to be given in a very similar way. Here it is to be given fog and gof both are said to be the identity function of x, then definitely you can say that g is said to be the inverse of this particular, and here you can just check the domain and codomain, here x to y then y to x, because here there should be no problem, this is r to r, this is r to r. So basically here let f of x equals to given as 10x plus 7. So this will be taken as y, and how we will calculate the inverse? Student, in the case of inverse, just we are doing a very simple work. In the given function, this y will be written in the form of x, then we will just change x in terms of y. This is the processing by which we will calculate the inverse. So how this particular function is to be written? So x will be taken as y minus 7 divided by 10. Is it to be clear? So y minus 7 divided by 10 here. So this particular function will be taken as g of y will be equals to y minus 7 upon 10, and this particular g is said to be the inverse, because here you can say that FOZ equals to GOF, this is also given as identity function, so that this g is inverse of f. So this g is inverse of f. Is it to be clear? And this will be written like this: g of x, you can say that, and you can say that it is x minus 7 upon 10. Student, you can just use the name of variable as x or y, there should be no problem, but we have to just mention the codomain and domain part of the g function. So in the very first question, a very simple thing, there should be no requirement to check GOF and FOG because it is already to be given. And suppose you want to do this calculation, then you can do also, because easily student you can calculate the FOGX and GOFX. Is it to be clear? If either of the part we will calculate and it is found to be the identity function either x or y, then definitely this G is said to be the inverse of F. So in the very basic and first question, only the definition part is very important. In the case of inverse, we have to just define this particular part in the theory section also, and where easily you can just write down the answer of this question. And this question has the answer as G of x will be defined as x minus 7 divided by 10, where G is to be defined from real number to real number. Is it to be clear? So student, next question we will take, but before that pause the video to note it down the answer. Then we will take the question number 2 of your miscellaneous exercise of your NCRT. So next question number 2 we are taking here. Next question number 2, you can see here. So in this question number 2, first of all, there f is any function w, and w means you can say that the set of whole numbers be defined as f of n equals to n minus 1 if n is odd, and f of n equals to n plus 1 if n is even. Then so that f is invertible, and find the inverse of f where w is the set of all whole numbers. No problem. A definition of function is to be given, means there are two parts are to be given. This particular function should be written as n minus 1 if n is odd, as well as you can say that this is said to be n plus 1 if n is taken as even. Then we have to just check whether the given function is invertible or not, and just we have to calculate the inverse of that function also, where w to w means this particular function is to be defined from the set of whole number to set of whole number. So basic question student is to be there. Now we will just see this question. A very important part is to be there. So in this question number 2, any function f is to be defined from w to w, and w is what? Set of whole numbers, and I think each and every student know very well about the whole number. And f of n you can write here n minus 1 if n is odd, if n is odd, and this is written as n plus 1 if n is even. This particular function is to be given like this. Now student, there are two definitions in the each of case. Either we are taking a set of natural number as odd or even, then we have to process them according to the given definition. Now the student, first thing we have to check whether the given function is said to be invertible or not. So we know very well, if any of the function is said to be invertible, then it should be a bijective function. It should be a bijective function. So bijective function means you can say that any function is said to be 1 1 or not, onto or not, and means if any of the function is said to be 1 1 and onto both, then in that case the function is said to be the bijective, and in that case you can say that the function is said to be invertible. So in this case student, just we have to say that we can say that we know that if f is bijective, if f is bijective, then it is said to be invertible. It is said to be invertible. So first of all, just for the invertible function, we have to check whether the given function is said to be bijective or not. So this logic we are applying here for the invertible case. And student, one more thing, for the bijective function, what we have to check? We have to check whether the given function is said to be 1 1 or not, or onto or not. Is it to be clear? So we will check the very first part, that should be the 1 1. We will check the 1 1 nature of this function first of all. Now student, in this particular case we will check the 1 1, but student, you can say that in proper definition means a common definition of n is not to be given here. Some basic parts are to be given, means here if n is odd, then the definition will be n minus 1, and if n is even, then definition is said to be n plus 1. So here to check the 1 1, generally we are taking the two numbers, but student, here there are four cases. Either we can take two numbers as odd number, either you can take two numbers as even number, either you can take n1 is even, n2 is odd, n2 is even, or n2, means there are four cases. In each and every case, first of all, if any of the case is possible or not, we have to check this thing. If the case is possible, then definitely we have to check whether we are obtaining n1 equals to n2 or not. So for the checking process of 1 1, we will take the four cases. First case, in the case first, if n1 comma n2 belongs to the odd number. Is it to be clear? Such that f of n1 equals to f of n2. So here what we are saying, student, this n1 and n2 belongs to the odd number, means we are taking the two odd number here. So in the case of odd number, this definition n minus 1 will be followed here. So this will be written as n minus 1 equals to n2 minus 1. So obviously student, you will get the answer as n1 equals to n2. So if we are obtaining the n1 equals to n2, then there should be no problem. Definitely we can say that the function is said to be the 1 1. So it is 1 1. So it is 1 1 case. Is it to be clear? Now the second case we are taking, student, second case we are taking here. So case second. In second case, if n1 comma n2 belongs to the even number, such that f of n1 equals to f of n2, and we are saying that in the case of even number, this particular definition n plus 1 will be used here. So this particular part is to be written as n1 plus 1 equals to n2 plus 1, and after simplification, student, again we are getting the result as n1 equals to n2. So in this case, so it is 1 1. So it is 1 1, means in both the cases, and suppose this particular function is to be found 1 1 in each and every case, then definitely it is said to be the proper 1 1 function. Now the third case we are taking. So the third case is very important. In third case, if n1 is odd, and n2 is even. Suppose we are taking the n1 as odd number and n2 is even number from the whole numbers, such that f of n1 equals to f of n2. Now student, n1. So n1 is what? Odd. So according to the odd definition will be written as n1 minus 1. And here f of n2. So n2 is what? Even. So in the case n2 plus 1 we will write here. Now student, you can just shift the n2 here, then n1 minus n2 will become 2. Now the student, very important thing we have to keep in mind, this particular thing n1 and n2 will give the result as even number, means 2 you can say that. But student, you can say that any odd number is to be there as n1 and any even number as there n2. So their difference will never be equals to 2, because you can take any of odd and even number and you can check the difference. Suppose we are taking 5 as value of n1 and 4 as the value of n2, because 5 will odd number and 4 will be even number. So basically 5 minus 4. So 5 minus 4 will be 1, not equals to 2. So there should be no n1 and n2 is to be there, means it is not possible. You can say that it is not possible for any kind of n1 and n2 as odd and even, means this case is not said to be the possible. And suppose student, any of the case is not possible, then we will not check for n1 and n2, and directly the particular function is said to be n1 and n2. So in this case, we are obtaining the result as n1 minus n2 equals to 2. So some of the student, suppose that they are thinking that we are not getting n1 equals to n2, so it is not 1 1. But student, you can just check the very important thing, n1 minus n2 will be 2. This should not be possible here, and this should not be possible, then this whole case will not be taken here. That's why we can say that the function is still 1 1, because this particular case is not said to be the considerable. Similarly, you can take the case 4. Where if we will take n1 as even, and you can say that n2 as odd, then we are again saying that f of n1 equals to f of n2. And student, here if in this case we have to write the result, then n1 plus 1 equals to n2 minus 1, then again n1 minus n2 equals to minus 2. Again the same thing is to be repeated. It is not possible. So the case third and fourth, both are not said to be possible. So student, we will not check the result of n1 and n2, means n1 equals to n2 is not to be checked for the case number 3 and 4, because these cases does not existed. Because here, according to the result, you are getting the some wrong data here. The one even number is to be there, one odd number is to be there, but their difference will not be obtained as the even number. So these case number 3 and 4 are definitely not said to be true. So in these cases, we will not discuss about the 1 1 cases. So student, overall, the two cases are to be possible, and in both the cases the function is said to be the onto. So overall what we are saying that the function is 1 1, means now the function will be declared as 1 1 function, there should be no problem. So here these cases are the very important, that's why I am saying this question is to be very important for us. So student, now we will check for the onto function, because 1 1 condition already we have to check here. Now we will check for the onto cases. Is it to be clear whether the given function is said to be onto or not? So before we will take the next part, then check the onto. Then before that, pause the video to note it down the theory answer of this particular 1 1 case. Now we will take the next part for this function as onto, means whether the given function is said to be onto or not. So the next part we will check for the onto. Again I am writing the particular function again. F of n is to be given as n minus 1 if n is odd, and you can say that this is n plus 1 if n is even. This particular function is to be given. Now student, we will check whether the given function is onto or not. So first of all, we know about the onto theory, because in the case of onto functions, definitely the student codomain elements has the pre-imagined domain or not. We have to check this thing. If each and every codomain elements has pre-imagined domain, then we are saying that the function is said to be the onto. Otherwise, function is not said to be the onto. Is it to be clear? So basically here codomain is what? This particular function is to be defined from whole number to whole number. Suppose we are here f of n will be taken as y. So f of n will be taken as y here. Then student, if we are taking 0, suppose we are taking 0, then 0 will be lie in which case? So you can say that 0 will be lie in the even case. So here if we will just take any of the value 0, then definitely 0 plus 1 will be 1. So definitely it will be an odd number. So in most important part, student, just we are saying that if any of the value, any of the even number is to be put here, then definitely you can just get the odd number here. Means, and all the odd numbers are to be the set of whole numbers. Means in all the cases of whole numbers, whenever any n is to be get provided here 0, then after we will take here 1, then after suppose we have to make the mapping here like this, then you can just understand the thing. Student, this is the set of whole number, this is the set of whole number. Here we have to write 0 1 2 3 4, here we have to write 0 1 2 3 4 5 and many more data you can write here. Suppose we have to check the pre-image of this part, we have to check the pre-image of this part, then definitely you can check the pre-image of this part, because here suppose n equals to 1 we are putting here. Then if n equals to 1, then the image of this means pre-image of this part will be this, no problem. Now next part means we have to just see the this part means 2. Suppose we are taking 2 here, then 2 is to be used here, so 2 belongs to the 3. Next we are taking 3, then 3 minus 1 will be 2, and suppose we are taking 4, so you can say that 0, suppose you are taking 0, then 0 will belongs to the 1, like the according to the definition. Either even number is to be taken, then we have to use this definition, odd number is to be taken, then this number, means each and every number will be occupied here, you can say that. And you can check for many more numbers. Suppose 4 is to be there, then you can say that 4 is even number, so 4 plus 1 will be 5, and any odd number is to be there, then like this. Means here you can just say each and every codomain element will occupy or will exhaust all the element in the domain. Is it to be clear? So no one element in the codomain is found to be left here which doesn't has any image. You can just check with the help of this mapping. Is it to be clear? So students, such type of things just we are just assume just by making these type of diagrams, then easily you can realize the things whether the codomain element has its pre-image or not. Is it to be clear? So definitely student, it is said to be onto, means you can say that for all y belongs to whole number, for all y belongs to whole number, definitely n belongs to the whole number. So it is onto. So it is onto. Means in the case of onto function, there should be no problem, and the result of onto we will check here. Then it should be y plus 1 if it is even, and y minus 1 if it is odd. So if we have to write the definition of n here, then it should be written as y minus 1 and y plus 1 again. Y minus 1, it is to be there where if y is even. y is even, and if y is odd. Is it to be clear? Because now you can check. Suppose you can take any of the even number as y. Y means from the codomain you can take. Suppose 2 is to be taken. So then 2 minus 1 will be 1. So 2 has the pre-image as 1. No problem. Similarly, you can take this part. Suppose we can take y as 3. Then definitely 3 plus 1 will be 4. So 3 has the pre-image as 4. Means all the elements in codomain definitely has the some element. So in the domain. So definitely student, this particular definition is to be get revert here. This f of n will be taken as y, and according to that we can say that this function is always said to be onto. Now student, you can say that the function is said to be 1 and onto both, then it is said to be a bijective function. And what should be the inverse? So you can say that this particular function is said to be the inverse. So inverse function, inverse will be it is written as n minus 1 if n is even. Here we can just change the name of variable as y as n, no problem, and here this is said to be n plus 1 if n is odd. Is it to be clear? So this is the final answer of the inverse of this function also. And if it is bijective function, then it is said to be invertible. Means it is bijective, and bijective means it is invertible function. Is it to be clear? So easily student, you can just provide the answer of these questions in a very systematic way, because here the things are the very simple things are to be given, and just you can use the particular theory part and you can just give the answer of each and everything. Is it to be clear? So student, in this particular question you can just see, we will start from here, and here we will check only the 1 cases, and these two cases are not said to be possible. Then in that cases we will not check for the 1, and in these cases the function is said to be 1, then always this function is found to be 1. After that, for onto student, just we have to assume the basic part as f of n equals to y, and you can make this type of mapping, and you can take any of the codomain element as value of this f of n, and you can just obtain the value of n, whether this n belongs to the whole number or not. So you can just revert the thing like this, and now you can just check by putting any of the value from whole number. Definitely all the codomain element has the pre-image in domain, and domain is also said to be given as whole number, no problem. So that we can say that function is bijective, so it is invertible function, and you can say that this is said to be the inverse. Here the name of variable you can use either y, x, n, no problem, but when the question should be given in terms of n, then definitely its inverse will be defined in the terms of n always. So this is the answer of this question of inverse. So a very important question is to be there, that is question number 2. So we have to keep in mind each and everything. So student, pause the video to note it down this thing. Next question we are taking here, the question number 3 we are taking. In this question number 3, first of all, a very simple question is to be given. F is any function given from R to R defined as f of x, that should be given as x square minus 3x plus 2, and we have to just calculate f of fx. A very simple part is to be there. Again student, we have to just find the composition of the f into f, means f is to be composed into itself. Is it to be clear? So we will just see the answer of this question. Then f r to r is to be given, and just we are saying that function is defined as x square minus 3x plus 2. So the next question number 3, is to be given as f is to be defined from r to r, and fx is given as x square minus 3x plus 2, and just we have to calculate the f of fx, or you can say that f of f we have to just calculate here. So easily student, f of fx you can write like this, f of fx. Now this particular fx you can write here x square minus 3x plus 2. Now again this particular part is to be taken as the input of this f function. So you can just say that here x square minus 3x plus 2 whole square. Then after minus 3 into x, so x will be x square minus 3x plus 2, and lastly we have to write the plus 2. Now student, easily you can just simplify the thing. First of all, we can apply the whole square here, but here the 3 terms are to be there. So no problem, you can take these 2 terms at a time. So firstly we have to write x square minus 3x whole square, a square, this is to be taken as a, then a plus b whole square. So a square plus b square plus 2ab. So 2 means 2 into 2 4, 4 into x square minus 3x. Now this is to be get multiplied, then minus 3x square. This is plus 9x. This is minus 6, and here this is plus 2. Similarly, you can just open this part always. So this is x raised to power 4a square plus b square minus 2ab. So minus 6x cube. You can just add this plus 4 and plus 2 plus 6, and plus 6 will be get cancelled out with this minus 6 here. So the remaining part we can write here 4x square minus 12 of x minus 3x square and plus of 9x. Now you can just simplify the result. X raised to power 4. This is minus 6x cube. Now 9x square, 4x square and minus 3x square. So you can say that 9 plus 4 13, 13 minus 3 will be 10x square. Is it to be clear? And similarly you can say that minus 12x and plus 9x. So you will obtain as minus of 3x. So this will be the basic answer of f of fx. So a very easy question is to be there, I think. Students, just we have to keep in mind the composition part. First of all, we have to write the fx, then this particular part will be taken as the input of this particular function f. Means in place of this in this function, in place of x, just we have to use this value, and then we have to just simplify, and we will use the simple calculation, then definitely you will get the f of fx. So I think this question is to be very simple.